Hi, and welcome to my game room. So this is like a little nook that my family likes to play games in, and we store our games here. And I thought it would be appropriate for this video because today we're going to be talking about probability. So when you think about a game, there are a lot of games like Twister that are based on skill. But there are other games as well that are based on chance, like the Crocodile Dentist. So if you press on his teeth, your goal is not to press the tooth that hurts, because otherwise he bites you. Or Yahtzee is another game that's based on chance. And then there are games that are based on luck and chance, like Go Nuts for Donuts. Chance, because it has such a strong role when we talk about games, this is a really good way to kind of talk about probability. So probability is, a probability experiment is a process whose trials are dependent on chance. And so what we want to talk about is what a probability experiment is and how you actually compute the probability for different types of events, essentially. So first of all, in Yahtzee, if we're looking at it, it's got 5 dice. Each die has 6 sides. Each side has a different number of dots, which we call pips. So one side has 1 pip, another side has 2 pips, and so on and so forth. And when you roll the die, you look and see which side lands up, and then you call that rolling A, in this case rolling a 2. So when we talk about rolling a die, this is a probability experiment. And each time I roll is a trial. So one of the things you can ask is, what are the odds that we roll a 3? Or what are the odds that we roll a 6? And so on and so forth. And of course, here's my cat coming to visit, but we'll let the cat kind of hang out for a minute. So in our probability trial, in our probability experiment, we've got different trials, which are the individual rolls, and what we have are outcomes. Outcomes are the individual things that could occur. So the outcomes for rolling a die is we could roll a 1, we could roll a 2, we could roll a 3, we could roll a 4, we could roll a 5, or we could roll a 6. So these are the individual outcomes for this probability experiment. We're rolling a die, and these are the different possible things that we could roll. So these are the outcomes. This entire set, this entire list of the things that could happen, if I was to enumerate or list out everything that could possibly happen in my trial, we call this the sample space. So there you go. My cat has now officially done a trial. And Gatsby, my cat, has rolled a 3. So the sample space consists of all the possible rolls that you could have. The other thing that we could talk about is we could talk about an event. An event is a list of some of the outcomes. Now your event could be all the outcomes. Gatsby has now rolled a 6. Maybe we should start keeping track. So we've got a 3 and a 6, and maybe he's going to actually run our entire probability experiment for us. An event is a list of some of the outcomes. Now it could be all of the outcomes, it could be the entire sample space, or it could just be some of the outcomes. Here's an example of an event. So an example would be like roll an odd. So that event would consist of rolling a 1, a 3, or a 5. So one of the questions that we start to ask ourselves is, what is the probability of a certain event taking place? Now, event is a list of some of the outcomes. So I could ask, what is the probability of rolling an odd? Or what is the probability of rolling an even? What is the probability of rolling a 2? That event only has 1 outcome. Events are kind of grouped outcomes that we might want to have happen. Maybe we want to roll an odd. Maybe we want to roll an even. So an event consists of some of those. There are different ways to determine the probability. So another way to determine one way to determine the probability is through what's called experimental probability, through the actual experiment. Now, Gatsby has already helped us with the probability for experimental, and that's because you actually run the experiment. You do a bunch of trials, and you look at the outcomes that you actually see show up. So the probability for an event, which I'm going to put P parentheses E, probability for an event E would just be some event that consists of some rolls. So, for instance, rolling an odd or rolling an even or so on and so forth. The probability of the event occurring would be the number of times that the event occurs, since you're actually running the experiment, divided by the number of times, the number of trials. So the number of times, you get an outcome in E, divided by the number of trials. Now, if I want to look at the probability of rolling an odd, then I can start rolling the die. So Gatsby's already gotten a 3 and a 6. I've got a 5. I've got a 3. I've got a 6. I've got a 4. I've got a 3. And a 2. And a 5. And a 2. And you do this some predetermined amount of times. Now, the number of times I get an odd, so if I put the probability, I'm just going to write odd right in there because that's the event that I'm talking about. The number of times I got an odd was 1, 2, 3, 4, 5 times. And the number of times I ran the trial, or the number of times I rolled the die, would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the experimental probability that I roll an odd is 5 out of 10. Because I actually ran the experiment. Now you can always do experimental probability. You just take whatever experiment you have, write down all the possible outcomes that can occur, and then just do the thing over and over and over again. Count how many times you do what you want to do, that's the event, and then divide by the number of times that you actually ran the trial. So, I mean, for instance, you could do, what's the probability that a slice of toast lands butter side up? Well, what are the outcomes? It either lands butter side up or butter side down. What's the event? That it lands butter side up. That's the thing that you're trying to look for. That only consists of one outcome, and that's fine. Now you push a piece of toast off the table a bunch of times. You count how many times it lands butter side up, count how many times you push the piece of toast off the table, and then divide those two numbers. That's the experimental probability. Other things can have a lot of outcomes. So you could talk about trying to do experimental probability for whether or not, say you have a 20-sided die. It's got 20 different outcomes, and whether or not it lands on a prime number. So you count up how many times it lands on a prime number divided by the total number of times you actually roll the die. There's just a whole bunch of different things you could do where you actually run the experimental probability. We don't always have to do the experimental probability. We could also do what's called the classical probability. And that is, if each outcome has the same chance of occurring, then you can just count up the number of outcomes in the event and divide it by the number of outcomes in the sample space. So this only works if each outcome has the same chance of occurring, but the probability of the event would be equal to the number of outcomes in E, the event, divided by the number of outcomes in the sample space, which we denote with an S for sample space. So, in rolling a die, I can actually check and see what the probability is of rolling an odd. There are 3 odds on the die. Probability of rolling an odd. There are 3 odds on the die. It could either land on a 3, a 5, or a 1. Those all have the same chance of occurring because the die is completely symmetric. Right? Every side has the same chance of landing up. There are 6 sides in the die, so there are 6 outcomes in my sample space. I roll a 1, 2, 3, 4, 5, or 6, as you saw on the previous board. So that means that the probability of rolling an odd is 3 out of 6. That's a classical probability. Surprisingly, the probability of rolling an odd with classical probability matched my probability of rolling an odd with the experimental probability. Doesn't always happen, but they should be close if you run enough trials in your experimental probability. So the more times you actually roll the die, the closer and closer you should actually get to the percentage being the same, not the number being the same. So what I mean by that is, if you roll a die 1,000 times, you might have rolled an odd 538 times. That's pretty darn close to 50% of the time, but it's off by 38, which sounds like a really big number, but you rolled 1,000 times. It's called the law of large numbers. It's that the percentage or the chance that you actually have something occur using experimental probability is closer and closer to the real true probability the larger number of times you actually run the trial. So classical probability, you count the number of outcomes in the event that you're looking at, divided by the number of outcomes in the sample space. And experimental probability, you run the experiment, count how many times you get something that is in the event, and divide it by the number of times you actually ran the experiment. The last one is called subjective probability. And subjective probability is when you make an educated guess about the chance that something actually occurs. So for example, you look outside and you see that it's cloudy, and you know that on cloudy days, half the time you get rain and half the time you don't, and you say, I think there's a 50-50 chance we're going to get rain. That's subjective probability. The ability for it to be close to actually true is subjective. It's based on an educated guess. It's still worth taking into account, especially if your educated guess is based on a lot of education. You've literally noticed that every other cloudy day you get rain, then you could say there's a 50-50 chance. So those are the three different types of probabilities. What we'll notice going forward is that in order to get really good at doing probability, we're going to do two things. One, we're going to look at rules. So rules kind of talk to us about how if we're looking at a specific event, maybe that event is built out of other events, and we can talk about rules on how to build the probability of our event using the probability of the other event. The other thing that we're going to use is counting. So one of the things that we'll realize is that when we look at probability, it is as simple as typically the number of outcomes in our event. Remember, outcomes are the individual things that could happen. Events are a collection of those outcomes. So you take the number of outcomes in your event divided by the number of outcomes in the sample space. The sample space is the list of everything that could possibly happen in each trial, and that gives you the probability. Unfortunately, some of our events are so large that actually writing down the number of outcomes in the event or outcomes in the sample space is virtually impossible, or physically, truthfully impossible for us to write them down, or even impossible for a computer to write them down. But we still want to be able to compute the probability for it. So what we end up doing is we use counting techniques. So going forward, we're going to find out about some rules that are going to benefit us and some counting techniques that are going to benefit us. So again, thank you for joining me in my family's Game Nook, and I will see you next time.